All right. So what we're going to be taking a look at here is annuities, loan payments. I don't know, you've ever on TV, there was a few years ago, this old guy had come on there, it's your money. Why not? You know, huh? Yeah. But what JG, good old JG Wentworth, yeah. But the commercial was talking about an annuity, which is basically a set number of payments over a specific period of time to give you the money that you have. And that's fine and dandy, but sometimes you need it up front, and that's what good old JG Wentworth was up to right there. So one of the things that's going to happen here is we would like to know what the future value of an annuity is. In other words, how much will it be worth? And one of the things about an annuity is you're continuously putting money in, as opposed to just taking a lump sum of money, dropping it in and letting the interest do the work. This is going and putting a, starting amount in and then adding to it all the time, and interest is growing on it. This is one of the things that they talk about for savings. Okay? If you're always saving a certain amount of your paycheck, putting money away on a continuous basis, on a regular basis, and a set amount of money, it can build up pretty easily. Of course, having that money is completely and totally a different situation. So one of the formulas that you need to have on your sheet is this one here, future value of an ordinary annuity. Okay. Now, talk about this one a little bit more here. You can identify what's what. $R is contributed at the end of each period. Now, say, for example, that you want to go and put into an account $100 at the end of each month. Okay? So you're putting that in. Pays an interest rate. So if you've got a savings account that maybe is making you 1% interest, which would be a swinging deal this day and age, you've got that going on there. So that's 1 plus. Now your N. Well, that's each period of 4 N periods into an annuity. How many periods is that going to be? Now, if you're putting it in monthly, obviously that's going to be 12 periods for X number of years. I mean, did it for 10 years, that's 120 periods. Okay. Pays an interest rate I at the end of the period. So again, we're going to have to keep in mind what happens to that. So let's take a look at this. A lot of times when you guys are working on these problems, you're not deciphering where things are coming from. Where do you have to put them? And I can go over that and walk through them. But you really need to be able to figure out what goes where and why. So what we're going to do here is I'm going to take this one out. And we're going to kind of pick it apart here a little bit. That's not what I wanted. There it goes. I mean, this is essentially a skill that you have to develop, and it does take time to develop. I understand that, but given these formulas and formulas that you end up having to deal with, you must be able to decipher what goes where. Okay. So I've got all the information sitting in front of me now. Now it says find the 5-year future value with an ordinary annuity of a contribution of $500 per quarter. So if we are doing this per quarter, how many times are we putting this in? 4. So this is going to be 4 periods. First thing that we need to do. into an account that pays, 8% per year, compounded quarterly. So we've got that reinforcement that we're dealing with that 4 periods again. Now, the interest rate is calculated per period. You'll notice that it doesn't necessarily say that, but it says the interest rate at the end of the period. So that means that we have to make sure that we take the interest rate, and our interest rate is 8%, and divide it by 4. So that is why wherever we see the I, we've got a 2. So that goes there, and that goes there. That's why those numbers are there. So when you're looking at this, you have to pick it apart. What is where? This is what I mean by this. So the next thing that I've identified how many periods, I've identified my periodic interest rate. Now, how many periods do I have to come up with? Well, we've got a 5 years that we're looking at, correct? And I have 4 periods per year, so that gives us our 5 times 4. So that is why we have 20 sitting here, because we've got 20 periods of time that we're going to be dealing with. Now, the only other number that I haven't identified where it goes is the amount that I started with in the beginning. So if our dollars are contributed at the end of each period, how much am I putting in? 500. So that means that the 500 is going to go here. This is how all those numbers go in. So, has anybody got a question about picking it apart and putting it where it belongs? Okay. Makes sense. You know how to see it and read it for those of you paying attention, following along, pretending you're interested. So, next one. Next formula that we've got here is the present value of an annuity. Now, if a payment of our dollars is to be made at the end of each period for end periods from an account that earns an interest rate of I per period, then the account is an ordinary annuity and the present value is this. Okay. So what is that going to be used for? How does that work? Now, the first one we had there was putting money in. This is the pulling money out. This is the good old J.G. Wentworth concept here, okay? So we're going to go through and we're going to do the same thing that we had done in the last one and see where the bits and pieces go so we understand what's going on. Oops. That wasn't cool. Hate it when things move on me. Yep. That's what I was trying to avoid. Okay, so we've got our information here again. Now, the situation is something that you always have to understand. I mean, we've talked about this through modeling. What is it that you are looking at? Now it says, suppose a retiring couple wants to establish an annuity that will provide $2,000 at the end of each month for 20 years. So what they're hoping for here is a bunch of money into an account. And if this money is in the account, I want to be able to pull $2,000 out for 20 years. Okay. That's what the idea is here. We're pulling it out. So what we want to know is the present value of an ordinary annuity. That's how they identify it. Okay. How much must the couple put in the account to establish the annuity? That's how much must be there. Present value. So let's walk through this. Payment R dollars is to be made at the end of each period. So how much money do I want? I want $20,000 or $2,000 a month. So that's my R. That's how much money I want to pull out of this thing. Now, for 20 years, so when I look at this here, is to be made at the end of each end periods. So if I am looking at 20 years and I want to get paid each month, how many periods do I got? I've got 240 periods that I need to deal with here. So my 240, you'll notice, is sitting right here. Now pay attention to this. This is negative. Okay, this is a negative there. So watch that when you get to the formula. So now that 0.005, again, because we're calculating the interest on this account every month, we need to have that periodic monthly interest rate. So we know it was 6%, and we're going to have to divide it by 12. So that's why you see this right in here. And my interest rate goes here and goes here. So what this is telling us is if I want $2,000 in an account, or I should say if I want to pull out $2,000 from an account each month for 20 years, I need to have $279,161.54 in that account. That's how much money I need. By the way, take what's 2,000 times 240? Oh, wouldn't that be 480, comma 000? There ain't that much money in there, is there? What you need to realize here and think about is the money that is in this account is earning interest for that entire 20-year period of time. You're pulling money out. So in order for you to have that $480,000 over 20 years, you need to start with that $280,000 approximately, so that as it earns interest, it lasts that long. This is what the problem is talking about. Whereas this one here, we were trying to figure out how much money we have to be putting in to get, or find out how much we get by putting in a certain amount of money. So it is possible to use the future value and the present value to figure out how much you need to be investing for so much money at the end for your retirement. And yes, this was a model. It is one of the models that I use. I just didn't use this one this year. So there is one more that we need to take a look at. And this is called an amortization formula. what this does is takes a debt and divides it out over a period of time to identify what your payments are going to be. Now, sometimes you'll hear things referred to as an amortization table, and sometimes you'll hear that used when it comes for making your payments. But here we go. I'm going to cut through this one here and see what's going on with it. Everybody always asks, well, where are we going to use this stuff? I hate to tell you this, but right now this section here has more to do with your lives than anything that we've really touched on in your whole mathematical career. And if you think about that, you're going, well, why didn't they just teach us this before? You have a vague understanding of the amount of math that you need to even come close to thinking about this stuff. Okay? Just think about all the stuff that you've been working on so far and how close it's been. So now let's see, I need to go back up and grab my amortization formula. Why in the world is this not working? So here we go. Now a couple wants to purchase a home with a price of $230,000. Okay? So their loan turns out they want to get that, but are they going to take out the whole $230,000? The answer is no. They have $50,000 for a down payment. So if they can get a 25-year mortgage at 9% per year on the unpaid balance, what will be their equal monthly payments? Okay. So what we need to do is work through this and figure out what is going to be what. So first offhand, if you're going to buy a $230,000 house, you put $50,000 down. How much are you really taking out for the loan? That's where the subtraction comes in, and we end up with just $180,000. So when I take a look at this, it says if a debt of $8, now your debt is what you owe. That's what you got to put back in. It's also called the principal amount. So that's our A, and our 180,000 sits here. Interest. Okay. Again, we're doing this idea of periodic interest because it's calculating the interest at the end of each period. You're paying this off monthly, so you have to divide it by 12. Your interest gets divided by 12. And so if we look at that, we see that the interest here divided by 12 equals this. So now you see where the interest comes in here and the interest comes in there, where it goes into the formula. 25-year mortgage. Well, a 25-year mortgage, and you're paying that every month for 25 years, that's your 12 times 25, so we got 300 payments. So that is N again, the number of periods. So 300 goes up here. Next, do I have any more information that I need for the formula? The answer is no. I've got the interest, periodic interest. I've got the amount that I borrowed, and I have the number of periods that I have to pay it back for. So they do all this wonderful calculation and they come out with this number right here. Okay, so what does that mean? This means that I am going to have to pay for my $230,000 house on the $180,000 loan that I took out at 9% interest for 25 years. I have to pay $1,510.55 per month. Now, mind you, I got that 0.3 there. Sometimes when they set your payment schedule up, they will have you pay an extra penny every 3 months or so, because they're not going to lose out on that, 0.3 of a cent. They are not going to do that. So, but anyways, you'd be looking at $1,510 a month. Now, that takes care of A. So, what is the total amount they will pay before they own the house outright? In other words, if you make this payment for 25 years, how much have you paid for that house? Well, you've got your 300 payments, so that means that you're going to have to take that and multiply it by 300, which is right there, plus you have to put the $50,000 down. So, for your $230,000 house, how much are you paying for this? See that 503 down there? You've almost paid for that house twice. I was going to say, that economic collapse that we had, back in the mid-2000s, this is where a lot of it was coming from. They were getting people to buy houses that they couldn't necessarily afford by giving them swinging deals for their loan payments, so they could get into the houses. And once they got into the houses, they could be making the money on the interest. Because whenever you're making a payment on the house, you're paying both principal and interest. So, can you see where people that love money would really love to get their hands on this? And a $230,000 house, that's average. Granted, up in this neck of the woods, it would be one of the nicer houses. You go down to the cities, and that's average. There are some places you can't touch a $230,000 house. So, questions on that? One of the things that, especially West Coast, there was a teacher I was teaching with when I was in Lee Center. Band teacher, he lived out in California. He sold his house, which was on the small side, bought a house that was twice the size, that was newer, and still had money left over. Kind of crazy, but that's the way life goes. So, how much did they actually pay in interest? Well, if you borrowed out $230,000, or I should say, that was how much you paid for the house, was $230,000. That's the principal and interest. When you subtract off that from that 530, you paid $273,000. So, mortgages are a big deal because the people that give you the mortgage, you pay the money twice. It's just the way it goes. So, back to this. That be the end of that. Now, what I want to know is, are there any questions on either one of those three examples on how we go through, pull it out? Because once you just plug it in, it is simply a situation of calculator exercise. Biggest deal is determine what is it that you're doing. Are you trying to figure out how much your money you are going to need and be putting in a set amount? Future value. Present value. How much money do I need now to get a payment over a period of time? Present value. How much are my payments going to be? Amortization.